Today, we're taking JavaScript to the next level by using the Fetch API to build real applications that communicate with servers, just like modern apps such as Netflix, Amazon, and social platforms. Imagine your browser is a customer ordering food from a restaurant. The browser sends an order, the server prepares the meal, the server sends the response back. That's exactly what Fetch does. The Fetch API sends HTTP requests and immediately returns a promise, a placeholder for a value that will be available later. Once the server responds, the promise either resolves with the response or rejects if a network error occurs. Now let's make our first real API request. We'll use JSONPlaceholder, a free testing API that allows developers to practice working with real server data. This URL gives us a list of users. Now let's request the same data from JavaScript using the Fetch API. Notice that we don't see the users yet. Instead, Fetch gives us a response object containing information about the server's reply. Let's quickly look at the most important parts of this object. Status tells us whether the request succeeded or failed. For example, 200 means success, while 404 means the resource was not found. Headers contain extra information about the request and response, such as the data format and server details. URL shows the exact address that JavaScript requested from the server. The response object is the package we receive back from the server. Later, we'll convert its body into usable JavaScript data using response.json. Getting the response is only the beginning. Now let's turn it into usable JavaScript data. The first promise gives us the response, and the second converts it into usable JavaScript objects. Now we can work with the data just like any other array of objects. Now let's display the fetch data on the page. We'll loop through each user and create a card dynamically, the same approach used by dashboards and many modern web applications. When data comes from a server, it doesn't arrive instantly. A loading state keeps users informed and makes your application feel responsive. Before we make the API request, we'll display loading users. Once the data arrives, we'll remove the loading message and display the user cards. This small improvement creates a much smoother, more professional user experience. In real applications, things can go wrong. The network can fail, the server can return an error, or the requested data might not exist. Let's understand the difference between common failures. A network error means the browser couldn't reach the server. A 404 means the server was reached, but the requested resource was not found. A 500 means the server received the request, but something went wrong internally. To handle network failures, we can use .catch to capture errors and display a better user experience. But there is an important Fetch API detail. HTTP errors like 404 and 500 do not automatically reject the promise. We need to manually check the response status. We can use response.ok and throw our own error when the request is not successful. Why doesn't Fetch reject on 404? Because the network request succeeded. The server responded. 404 is an HTTP response, not a network failure. Most applications don't just read data, they create, update, and delete it. These four operations are called CRUD: create, read, update, and delete. So far, we've mainly used read with GET requests. Now let's send data back to a server using a POST request. A fetch request can be customized with options like the method, headers, and body. Method tells the server what action we want to perform, such as post for creating new data. Headers provide extra information about the request, like telling the server that we are sending JSON data. Body contains the actual data we want to send. Since servers expect JSON, we convert our JavaScript object using JSON.stringify. Now let's see what happens behind the scenes using Chrome DevTools. We can inspect the request method, headers, sent payload, and the server response. Understanding this request flow is a key skill for building real-world applications that communicate with back-end services. Every application communicates with servers using HTTP methods. These methods tell the server what action we want to perform with our data. The most common methods follow the CRUD pattern. Get reads data, post creates data, put replaces existing data, patch updates part of the data, and delete removes data. For example, a shopping cart uses post when adding a new item, patch when changing quantity, and delete when removing an item. Instagram uses get to load posts, post to upload content, and delete when removing a post or comment. Spotify playlists use these same ideas: get to load songs, post to add songs, and delete to remove them from a playlist. Today, we chained promises with then and .catch. It works, but professional JavaScript has become even cleaner. In the next episode, we'll replace those chains with async await, making asynchronous code easier to read, easier to debug, and easier to maintain in real applications.